Let's do just that. Number 9, and we have the limit as t approaches -1 to t to the 5th minus t to the 4th over 5t squared plus 4, everything to the 3rd power. We have to do that no matter what, without even thinking, because we need to determine the type of limit. I have no choice. I have to plug it in. That comes without question. I have to plug it in. And of course, I'm not going to raise to the 3rd power yet. I have to plug it inside. I have to determine the inner. So can anyone plug it in and tell us what we get? So plug in -1 in here, -1 in here, -1 in here, and tell me what you get, and then we'll take it to the 3rd power. If it's a number. But if it's 3 over 0, then it's trouble. So what do we get? Can anyone give us the numerator?
Is it -3?
Yes, -2 minus 1 is -3. Awesome. Can anyone give us the denominator?
Nine.
Very good. Notice that I dropped the limit operator. We are not allowed to drop the limit operator before we apply it, but I did already. I applied it. That's why there is no limit here. So the numerator goes to -3, the denominator goes to 9, the whole thing inside is -1/3, and I have to use the power, and I get -1 over 27. It was a nice situation. Plugging in, solve the problem. We did not encounter any of these. Not this and not this. It was a very nice situation like this or that. We plugged it in, we got the answer. Okay. Now, more sophisticated situations in which we have to use a lot of algebra. 11 through 34. You choose one for me, and I will choose one for you to work on. So you choose one for me first. Anything you want me to work on, you choose, and then I will choose one for you. Anything you want. They're all different. Look at, they're all different situations. That's why I said, first, I have to make sure I understand the case I am facing, the type of limit I'm facing. That's why I have to plug it in first. There are situations in which plugging in, very rare, but they are, plugging in at the beginning is not possible. And I will show you one. Unless you want to choose a different one for me, I would like to show 28 or 31. You cannot plug in from the beginning in this one. You cannot plug in from the beginning in this one. I'm not changing the rules on you. I'm only saying there are exceptions. In general, I have to plug it in. It's a must. But there are situations in which I can't do that from the first step. I have to wait till the second step. So which one you choose for me?
28.
Okay, let's look at 28. In 28, we have limit as t approaches 0, 1 over t minus 1 over t squared plus t. You understand that I cannot use a limit law because the limit of this we just graphed a few minutes ago does not exist. I don't care what this one does. I found one or the other that whose limit does not exist, so I cannot separate it. The limit law does not apply here. I cannot even plug it in. So first step is must simplify this. So how do I simplify it? So I have limit as t approaches 0. This is factorable. Can anyone factor the denominator for us, please, quickly?
T times the quantity of t plus 1.
Awesome. Very good. Can anyone give us the least common denominator? I am hoping that no one has difficulties with this because it will be a problem moving forward. Please. Anyone other than Amanda can tell us the least common denominator, please.
Times t plus 1.
T times t plus 1. Very good. So obviously only this one needs a t plus 1. There is nothing, no adjustment, or you can write 1. T plus 1 minus 1. Oh, nice. Nice. Okay. Then I'll write it one. So please do not drop the limit operator. We have not applied the limit operator yet. Do not drop the limit operator, please. So equals limit as t approaches 0. I have t in the numerator, and I have t and t plus 1. Nice, very nice. Now you can drop the limit operator and give the final answer. Who would like to give the final answer for this one, please? Amanda, you're not banned. Of course. Can anyone give us the final answer? And this is exactly the moment the limit operator disappears because we apply it.
Is it 1?
Over?
1 over t plus 1.
Yes. So, no. So you said, so when t approaches 0, the numerator approaches 1. And when t approaches 0, the denominator approaches, you said it.
Isn't it 1?
Exactly.
1.
So then the answer
Yes,
is
the whole
1.
thing 1.
Awesome. That's it. Okay. Now, I would like everyone to work on one. We still have a lot. We have to look at the ones with radicals. We still have a lot. But I would like us to work on one limit on your own. Let's say 14. 14. The limit as x approaches -3 from x squared plus 3x over x squared minus x minus 12. And I would like you to put the answer in this second discussion. I'll make it available. So please work on this.
Did you want our answer in Canvas you said?
In the discussion. I'm making it available right now.
Okay, thank you.
Just put your answer in there. Hopefully we have time to work on it together.
With the discussion or answer previously?
It's discussion 1, chapter 2. I didn't copy anything in there, just put in an answer. Do you see it?
Yes.
Did I do something wrong?
No, I can see it now. Thank
Okay,
you.
thank you. How are we doing? Is it done? Is it done? I see 1, 2, 3, 4. I see 4. So I'm waiting for 4 more. Two more. I like to have the time to show it to you. One more. I will not be able to grade the second response. I can only grade the first one. Okay, so let me quickly go through this. So when you plug in -3, you have 9 minus 9, which is 0. When you plug in -3, you have 9 plus 3, which is 12, minus 12 is 0. So this is nice because there is hope. So what I'm going to do next is, of course, I'm going to factor x plus 3, and the denominator into x plus 3 and x minus 4. And that's the whole idea, the whole trick, to eliminate the problem. So now the limit is from x over x minus 4 when x approaches -3. The numerator goes to -3. The denominator goes to -7. So the limit is 3/7. Thank you so much for your patience.